All right, I totally forgot to start recording. So, to reiterate what I said for the last 5 minutes is yes, go ahead, Mitchell.
So the next chapter 7 assignment is due Friday?
Yeah, currently the chapter 7 is due Friday. How many people are finished with it? 3? How many of you have started it? Is that everybody? Would Sunday help?
Yes.
Or does that mean you're just not going to start working on it anymore until Sunday? Because I have so many times people want, it's due Tuesday, so it means I'll start Monday. But if it's due Friday, it means you start Thursday. I mean, as long as you guys are working on it, I'm okay with moving it till Sunday.
Yeah, that just give me more time to work on it and get it to run.
Okay, because I realize a lot of us have jobs, and weekends are helpful, but I also realize sometimes you get busy on weekends, so I've actually had people appreciate having to do on Fridays, that way they don't have to do it on the weekend. Because if you do it during the week, it's kind of one of those things. All right, I'll move it to Sunday. Make sure you work on it. Okay, thank you for bringing that up. Okay, so I just mentioned a second ago before I started to record. Let me bring that picture back up. It was, if I can find the darn page, it was this one right here. In the end of this first section of slides, we talked about letter frequency and how E was the most popular letter. And since this is obviously a cybersecurity degree for the most of us, some of you are not, but I teach a cryptography course where this becomes very important. Now, this next section talks about a method here called remove matches. Okay? I went ahead and entered the method for us. Okay? And I'd like to walk through it because I know how it works. We're going to walk through how it works. So this is one of those things that is confusing at how it works. Okay? So I'd like you to type it in because you're going to need this. And I want to walk through using it and we can see what the heck is it doing. Okay? Alright. So there's remove matches. Anybody know where I got remove matches from?
From the book,
Where?
page 272.
Really? I thought it was like at 107. Should be chapter 3.
Oh.
It's actually in... it's actually in chapter 3, by the way. All right, I'm going to type in the text they have on the page behind it now. Text equals, are there 25, 26, or 27 non-letters to remove? I'll slide it back in just a second. Okay, actually let me go. Just trying to keep it on the screen so y'all can see everything. Alright, because this is one method. I know what it does. I've walked through it myself. It's just, I feel there'd be a better way to write it, but it does work perfectly. Okay? Okay. Some of you catching up here? Getting it entered? Right. Now I'm going to say text equals text dot lower. Most of you got this? Okay. Okay. Getting close? Hopefully you're getting close. Let me pause this just for a second. Okay. I just ran my code here. So that's one bad thing about pausing. I keep forgetting to unpause. Okay, I just ran my code. I'll run it again. Okay, I ran this by hitting F5. and it ran, and it says, are there 25, 26, or 27 non-letters to remove? Then what the heck did that method do if it just printed out the normal text? Does anybody know? I didn't call the method yet, okay? That was a trick question, and she was right on the ball. Basically, I didn't call the method yet. I just wrote the method and didn't even use it, okay? All right, so now I'm going to say non-letters equals remove matches text A, B, C, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Just the alphabet, in case you're wondering. Just the alphabet is all it is. Then I'm going to say, I'm going to say print non-letters. Alright? That's all I did. Okay? So I made a variable called non-letters. I called the method remove matches. I passed it my text, which was are there 25, 26, or 27 non-letters removed. And then I passed it the alphabet. Okay? Now I'm going to run this again. And I get, are there 25 or 26 or 27 non-letters? That was the first text. Now the second line, actually remove that first line so it doesn't confuse you. Hold on. Let me comment this out. So we're really only seeing the results of the non-letters. Okay? So it actually prints. So what did it print? Does anyone know? So what are the non-letters? Right there on the screen. Should be that difficult. What's the first thing it printed? No. What? A space. See, there's a space right here. There's actually two spaces. A 25, a comma, another space, 26, a comma, two more spaces, 27, a space, a dash, two more spaces, and a question mark. Okay? That was a trick question, Chris. All right. Because what it did is it removed all the letters. So we got this space, and so on and so forth. Okay? So what... All right. What did it do? Well, let me type this next part in. Then I'm going to say text, no, not test, text equals remove matches, text, comma, non-letters. So we know the first time we ran it, when I did print non-letters, it printed everything that was not a letter. Okay? Now what's the next one going to do? So this time we're saying remove matches of non-letters. Now I'm going to run this, and I get all the letters without the numbers. Everybody see what that did? It removed all that. Okay? Well, I want to actually walk through the way this method works because it's kind of confusing. I'm going to comment out all my text here. Go ahead, Mitchell.
Yeah, but you just removed all the spaces, too.
Right, because spaces are non-letters. Because when I ran this, you'll see it's removed all the spaces, all the numbers, all the commas, and the question marks. All we're left is the letters.
Okay, so if you wanted to keep spaces, would you put like a space
Within the alphabet, I would have left a space in there.
Okay.
This is similar to what we did for, wasn't one of our second program or something where we had to remove all the special characters? Remember that? You could have used something very similar to this. Okay? Now, I want to comment this stuff out because I need to walk through this because even when I look at it, it's a little bit confusing. Okay? I just commented out my code at the bottom. I'm leaving the method alone. So I'm going to call it. I'm going to say print, not with capital letters, print remove matches. I'm going to pass it test, and I want to put in that alphabet. Where's the alphabet string? Here it is. Okay, I'm going to put the alphabet in here. Okay, So that's what I have in here. I need one more parenthesis. All right. So what will happen when I run this? I'm basically saying remove matches. I'm passing it the string text test and the alphabet. What is it going to print? Anybody know? Any takers? Okay, well, let's see if he's right. I'm going to make it so you can see it easier. I'm going to say alpha equals, I'm going to make this just so it's easier to see on the screen. I'm going to remove this here and put alpha. That way you can see the whole thing on the screen. That's just going to make it easier so we can see it. That's all I did. So, Ryan over there said it's going to print nothing. How many people agree with Ryan? 2 people. 3 people. So the rest of you do not agree with Ryan. All right, let's run it. Got nothing. Well, let's figure out what the heck this did. All right? Because when I first looked at this, I'm like, what is it doing? All right, let's walk through here. A lot of times they call it tracing. Okay, so we're calling my matches. We're passing it tests. Everybody agree with that? Okay, so my string is equal to test. I'm just going to write down what it is here so I can keep track of it. Okay, then we're saying new string equals nothing. Y'all agree with that so far? Then we're saying for CH in my string. What is that? So what's the first thing that that line is doing? This line is doing right here. What is CH equal to? Okay, it's a character in a string, but does CH mean it's a character? Actually, I could have called this CH. I could have called it apple. It doesn't matter. So what is the value of string when I'm first running this? Now I got this air conditioner right above my head. It's hard to hear. Someone's got to know. No? No one knows? Someone's saying something. I can't hear you.
I'll say nothing, but
Well, I'm going to do print CH. I'm going to break so it stops. Okay? So now we're going to run it. We're going to, actually I need to comment this out. That won't cause any problems. So I get a T. Okay? What this thing did was, remember we passed it test right here. And then we created a blank string. And so for CH in my string, this CH is equal to a T. So it's going through my string one character at a time. Okay? So the first time through, we know it's a T. Okay? Now, next thing it says, if CH in my string. What does that mean? So what is CH equal to at this point? It's a T. So right now, when we're starting out, CH is equal to a T. Just a T. So if CH in my string, that returns either true or false. Is it true or false? It is true. Okay. What's my string? Test. So I'm checking if T is in test. And the answer is true. Y'all agree with that? Because right here, it's saying if T in test. Everybody got that? So that's true. Since it's an if statement, if it's true, we continue on to what's indented. Now I'm saying if T not in remove string. What's remove string? The alphabet. Okay, because remove string is right here, which is right here, which is this. So, if T, because we know CH is T, if T is not in the alphabet, is it in the alphabet?
yes.
So it is in the alphabet. So, but if it was not in the alphabet, then my new string would be my new string plus the new character. So I'm going to see what the heck new string is. Oh, spell it right. So what should I get first time through? Should I get anything?
Space was key.
Let's make sure. I'm going to do this. I'm going to do this. A lot of times I'll do this to see what's happening. Everybody know why I just did that? So we know it's going to print the 2 dashes. I want to know, is there anything between the dashes? That way if there's a space, I'll be able to see. Okay, so when I run this, if T is not in the alphabet, it should print this out. Okay, let's run it and see what we get. Got nothing. Why did I get nothing? Because T's in the alphabet. Okay, let's test that theory. I'm going to remove T from the alphabet. See, I always like doing this so you can test it. What's it really doing? See, everybody say, I just removed T. T is no longer a valid letter in the alphabet. Aha! So that's exactly what's happening. So everybody's following me? See how this program's working? Alright. Let's put T back in. And now it should not print anything. Which is what it did. It didn't print a darn thing. Alright. So far so good? Okay, what's the question, Mitchell? Do you have not in right here? And is it indented all correctly? Let me come look real quick. Hold on. What I like to do when playing with this stuff, I put a lot of print statements and break statements in there to see exactly what it's doing, but you got to make sure you remove them because it has detrimental effects. Break causes it to quit. I mean, okay. So the first thing we checked if T was in there, and since T was in there, we did nothing. Okay, you agree with that? So then we're at the end of this if statement. So now let's remove these 2 statements. Okay, so that's the way it was. So we know it did not print anything yet. This new string is still blank at the end of T. Then we're at the end of this if statement, end of this statement, so we come back up to here. So what does CH become now? Was it? E. It becomes E. Because remember, it's going for CH in new string, or my string. So now CH becomes E, and so on and so forth. It runs and everything else. Okay? So we know since all the letters in test are in the alphabet, it's not going to print anything. Do you agree with that? So if I run this, I should get nothing on the screen. I get nothing. Okay? Now, to make sure it's actually working, I'm going to put a letter in or something in here that's not in the alphabet. I'm going to put a 5. Do you agree that 5 is not a letter in the alphabet? So now when I run this correctly, it should return a 5. Print only a 5. Okay. Hold on. Did I not put it in the right place? Oh, duh. I need to do it up here. Sorry. I need to do it up here. I did it on the wrong part. This is just where I was keeping my variables. But I needed to do it right here. So now let's run it, and we should now get a 5. And we did. We got a 5. So, does anyone see the problem I have with this method? Okay, so we're calling this method. Okay. We're calling it, passing it test in the alphabet. I just don't think the name's correct. Remove matches. So I guess it's removing test because test is a match. Everybody see that? But the way they're using it, so now let me comment this out. Actually, comment this out. Let me bring my original test back. My original text. Okay, right here. And I'm going to replace this with alpha, just so you can see it all on the screen. Is the only reason I'm doing that. So when I run this again, we get the 25, 26, 27. Remember all that stuff? Okay? But it just seems that it's... I just don't like the way it works. I mean, it works fine, but we're passing it that entire string. Are there 25, 26, 27? And it just seems like it's... I don't know. I just don't like the way it works. I mean, I like the way it works. I don't like the way it's named. Okay? But everybody understand how it works? Everybody got that to work correctly now? Alright, and if I remove... Oops, sorry. If I remove this, now I should get just the word. So what we're doing is we're using it to return the non-alphabetic characters. And then we're using it again, kind of like backwards, to return the letters that we didn't remove. See what I'm saying? It's kind of like, there's some called overloading. We use the same method name for two different things. It's kind of what we're doing with it. The first time we ran this method, the first time we used it to return the numbers and the commas and the spaces and the question marks. Then we run it again to do it the opposite way. Return everything but that. That's why the name's confusing to me. That's why I just had an issue with it. Okay, but does everybody understand how this method works now? Okay. Now, all right. So we walk through that. Then they get down here to letter frequency. But letter frequency uses remove matches, but also uses remove dupes. Okay? You need that code, so don't delete it, by the way. You need it. Okay? They also have one called remove dupes. And I'm going to bring up that one since I happen to have that one as well. Again, this is from chapter 3 as well. And if you want to type that one in so you can walk through, that's fine. We're going to explain what this one does. And they don't have us running it. It's just there. So we'll bring it back up. So if you want to run that one, you can. And I want to see what it does. Okay, so yeah, if you want to type that one in, go ahead. I'm going to say alright. Okay. If you want to type in remove dupes, go ahead and let's just see what it does. Okay, I'm going to pause this for a second while you guys are doing that. Okay, here we go. Haven't tried it. And tests. So what did it do? How did you guess that? Okay, let's look at it and see what it does. So remove dupes receives the string. And in this case, it was test. Okay? It makes a new string. Okay? It's a new string. It starts off as being blank, okay? Then for CH in my string, so the first time it's through, CH is equal to, what's it equal to? T. Alright, then we're saying if CH not in new string, so what's new string? New string is blank. So if CH, which is T, is not in new string, it's not in there. Do you agree? If it's not in there, then add it to it. So then new string becomes T. Then we're at the top of the for loop again. So what's CH become? E. So it becomes E. We get down here. If E not in new string, which it's not, then add it to it. So this string keeps growing. And then we add S to it. And then CH becomes T again. So this is T again. And so if T is not in new string, well, new string already has a T, so it does not add it to it, and it just returns new string. See how that works? That one's kind of neat. Okay. What? Yes, it is. I like that one much better than the other one. Okay. Now, this is the long one we need to look at. All right, they have something called letter frequency. And I was nice enough to type that in for you as well. Okay. If you want to type it in, you can. But let me open up another file instead. Okay. I want to open up this one because it actually has all of them in it. You'll see they're all in there. Okay. So if you want to type in this top one, I know it's longer. You don't need the comments in there. I just did that so you knew where they came from. All right. And then we got to walk through what this thing does. Because if you're how many of you are cybersecurity majors? Isn't that most of you? Okay. So this would definitely help in your cryptography course. Definitely. Okay. So let me pause this while you guys are putting that in real quick. And then we're going to... Yeah, we need one more method now. It's called getFreq. It's right there. And we will explain what this thing does. Okay? And I got a bunch of extra text at the bottom. So type in get freak. It's literally one line.
At the very bottom? Okay.
Yeah, type in this get freak right here. And then don't worry about after that because we're going to do some other stuff. But just stop at get freak. I'm going to put a file up there real quick, a D2L. So I'm going to have to get out of this screen. So get freak is very short. I'll come back to this in a second. I just have to get a file up there for you. Or else you're going to have a problem. Come on. We're waiting. Okay. We're going to go over here. Wow, 4 submissions already. Alright, we're going to go over here to Chapter 8. And I'm going to upload a couple files there. So if you want to download these files, you can test it the way I'm going to test it. I'm going to upload wells. I'm also going to upload IOC. Okay? There. I uploaded wells and IOC under Chapter 8 in D2L. So you can test it the same way I'm going to test it. Okay? Alright. So most of us got this typed in. Let's, first of all, I want to comment out everything down here. Yeah, I got a bunch of stuff. Just ignore the bottom stuff for the moment. I'll explain what it's doing. This is somewhat in the book as well, just not 100%. Okay. Alright, I'm going to uncomment out that line. Okay? So I'm going to run, this will be a very good test to see if you wrote or typed your stuff correctly. If I run this, what should it do? Anybody? Should do nothing. Does absolutely nothing. Which is kind of good. So if I do this right here, if I call LF for letter frequency, I pass it the word hi there, I get nothing. Why do I get nothing? And I'm not printing it out, exactly. So I want to print it out. So I'm going to go over here and print. So I want to print LF. And I get that. Okay? Alright. So I typed, forget that stupid thing built into Windows. If you move a window quickly, it minimizes everything. So I call LF. Oh, no, I made a variable LF, and I called letter frequency, passing it the word hi there. Then I printed the result. Okay? And when I run it, I get that. So based on what you see on the screen, what is this? What data structure is this? Anybody?
The frequency of each letter.
It's the frequency of each letter, but what type of data structure is it stored in?
A list.
It's a dictionary. How do we know it's a dictionary, Cameron? It's got the squiggly braces at the beginning. If it was a list, it would have been square braces. Very good. Okay, that's one way you can tell. And since this is a dictionary, it's keyed on the letters, and then this is the frequency of the letters. Okay? Now, it's EITRH. Everybody see that? EITRH? What happened? Wasn't it EITRH a second ago? Hold on. Now it's TEH. Let's run it again. Now it's HIR. Now it's TEH. Dictionaries are not ordered at all. There are ways to order them, but it's very difficult. So you're going to get different results each time. I wanted you to see that. Okay, now let's go in and see what the heck we just did. Alright, so we passed hi there to letter frequency. What does letter frequency do? Okay, so it receives hi there as text, then it converts it to lowercase. Okay? Then we use remove matches. So what we're doing is we're removing anything non-alphabetic. We're removing everything but the letters. We already saw how that works. Then we're removing duplicates. So if my text is hi there, did we remove any duplicates? You have 2 E's and 2 H's. Everybody see that? We have 2 E's and 2 H's. So no, it doesn't matter if it's capital because we already converted it to lowercase. Yeah, so everything was converted. If we didn't have that statement, they would have been considered Actually, that's a very good question. Let's comment that out. Let's
Have a capital H and a lower H.
exactly. Now I'll have a capital H and a lowercase h. What? Did I not do it correctly?
Shot you in the foot.
Killed me. Hate when that happens. It's got to still be converted to lowercase. Where the heck is it converting to lowercase? I don't know. Well, we don't care right now. We're going to pretend we didn't do that. I'm going to rewind. I never did that, so we're not going to look stupid. So if you just watch this recording, pretend we didn't do that. Okay. I don't know what I did, to tell you the truth, and I don't feel like looking at the find it right now. So we removed everything that was non-alphabetic. Then we removed duplicates, so we removed the H and the E. Actually, we did it right there. Okay. Then we removed matches again to do the opposite. Remember how the first time, it's like when we ran it, we left the non-alphabetic stuff, then we used that to remove it again. Remember that? We did that with are there 24, 25, 26, or 27s. First time we ran it, we kept the commas, the spaces, and all that. And then we ran it the second time, we used that to remove from. I guess we could have made a string of all non-alphabetic characters, but it's kind of, I like the way they did it. It works, it's just, I don't like the naming of it. Then we create this. What the heck does this mean? What's that?
That
What?
turns it into dictionary?
It's exactly. It creates a dictionary called L count for letter count. Very good, Chris. Then we want to know how many total letters there are. So it's checking the length of text. Now, remember, text has already been deduplicated. There's already been everything else. Okay? So for each character in text, so we're going through each one. Okay? So it's going through each one, and we're using get, so we're getting each element from the dictionary. We're getting the results of character, each character. So we're getting the number of whatever letters we had in there, an I and a T and all that. And the whole point of the +1 here is because they always start at 0, so we're adding 1 to it. Okay? And then we're going through that whole thing again and dividing it this time by the total number of letters. So we're doing the number of E's divided by total number of letters so we can figure out the percentage of E's. Okay, so it's really pretty simple. All right. So when you ran it here, letter frequency, when you ran it, it comes up and tells us the frequency or the, I guess it's not the probability, the percentage of H's and I's and R's and so on for each letter. Now, if we added those up, those should approximately be 100%. Do you agree? Let's find out if that's even close. I'm going to add up. So if I add up 0.28 plus 0.14 plus 0.14 plus 0.14 plus 0.28 should be close to 1. And we're very close. Okay, so it did work correctly. So everybody with me so far? That sucks reading it though, so we need to fix that. Okay, now don't worry about this next part. We're leaving that part out, but we're going to get down to right here. Okay, this other part's going to be reading from a file, but we're going to forget that for the moment. Okay, I'm going to now make a list. Okay, what we're doing there is I'm saying my list, which is a new list, is equal to LF, again, LF was the frequency of the letters. So we're making a new list of the items in the dictionary. So we're creating a list based on the dictionary. Okay?
Why do you have that three?
I'm going to get there in a minute. I'm going to explain it to you. I commented it out at the moment. We're going to look at that part last. Okay? All right. So we created a new list. And now I'm going to just do this. Now I'm going to sort it. And I'm going to explain how that works in a second. Then we're going to go through the list and print the results. I want to see what this does. Okay? I'm going to run mine, see what we get. Well, look at there. If you look at it, we got the number E's, number H's, and you notice how they're sorted. So, based on this word, hi there, what is the most common letter? I think. Based on hi there, what's the most common letter? The E and the H. They're identical. That's why they had the same result. So we have the same amount of E's and the same amount of H's. Okay? So that's why they're at the top, since we sorted by that. Then we have T, I, and R. Now those are all the same because there is the equal number of those as well. Okay? Now I'm going to change the string and make sure it works with something other than hi there. Hi there. How are you today? Okay? Now it should be a little different. I'm going to run it. So now, based on that new text of hi there, how are you today, E's most, actually E, O, and H are the same, but the others vary. Okay. You bring it down so you can see all the results. Okay. Everybody kind of with me? Alright. Don't do that. Luckily, I have this somewhere. This one. Alright. So yeah, we were down here. Okay. Ben asked what the heck I did that for. Well, let's look at it. I'm going to uncomment out that, and you can tell me what it does. What did it do? Let me show you what I did again. This was commented out, and that was the results. Okay? Now, when I remove the comment, I get that. It gives me the last three elements in the list. Okay? Remember that whole range thing? So what if I did this? Give me the top three.
Did you do -3?
Actually, I don't think you can. Actually, but you could do this.
No, in front.
Well, let's try it at the end. You should be able to do that. Okay, yeah, that works. I don't think... Can you do it in front? I never even tried that. Whoops. Don't hit that. Hit that. Oh, I guess you can. So, weird. Okay, but that's just returning 3 of them is what it's doing.
Doesn't it return the last 3?
Yes, this is the last 3.
No, with the -3.
Oh. I don't know. I've already deleted it.
When you did the negative three in front of it or whatnot, it gave you more letters than the original one.
Did it? No, it had -3 at the end because it gave me... What it basically said was starting 3 from the end. It gave me 3. I don't know, but... It's weird. Alright, so let's just leave that... I actually want to leave this off. That's why I had to comment it out. Okay? I want to see all the results. Okay? So far, so good? Now let's talk about this other thing here. This thing. Okay? When you sort, you can do reverse, first of all. If I say false and run it, you'll see it'll be sorting smallest to biggest. When I sort reverse true, it does biggest to smallest, like ascending and descending. Okay? Those of you working on your program should know what that does. Okay? Now it's biggest to smallest. Well, what the heck is this key? Well, the sort method can take two arguments. The first one is what to sort on. Okay? And since our list has multiple items in it, get freak right here, okay, is actually saying sort on the second element. Remember, when we run this, you'll see it has an O and then the number, an H and then the number, and an E and then the number. Okay? So this is telling it to sort based on the first element, and it goes 0 to 1, so it's really the second element. Everybody see that? I don't think I needed this. I think this was just extra. Yeah, I don't think you need. Yeah, you don't need that. I just was playing around with it. Okay. Now let's change it so it uses something. Up in D2L, I just put wells. Okay. They talk about wells in the book, and it's actually, I'll show you what it is. It's Word of the World from H.G. Wells, the entire book. It's free. I didn't steal it. You get it from Gutenberg.net. Okay. But the book's talked about, so I downloaded it for y'all. So I'm going to change this. Well, if you want to test this, yes. I mean, you don't need to, but... Okay, I'm going to go in, I'm going to remove this, and now I'm going to comment this out, just so those don't do anything. I'm going to open up the file wells. I'm going to read the file wells into text. Okay? Then I'm going to check the frequency of the text of War of the Worlds. Everybody see that? So I replaced this statement with these three statements, just so I can use the book. Okay? So if I ran this, what is this telling me? So it's telling me every letter in the alphabet, but what is it telling me? What is the most popular letter? E, exactly. Now, down here in the book, it shows it that way. If you're copying it out of the book, you get this. Okay, and if you look at that, there's no Z's. Do y'all agree there's no Z's according to that? But it's kind of misleading. There are Z's, just a small percentage of them. And that's why I changed this to say 8. That way we could see enough decimal places to realize that there really are some Z's. See, there are some Z's.
So all that number was just to change the decimal position.
Exactly.
So you could put 5, 6.
Oh yeah, let's put 6 in there. It's the number of decimal places. Now we have 6. See? I could put, I don't know how big, I don't know how many we could go actually. Let's see. Let's put in 60. I don't know. Let's see what it does. There it goes. Now it's 60. Wow. Yeah. All right. So everybody see how that works? So by doing that, now I also put a file up called, let me change that back to 8, just so it's not all the way across my screen. I also put a file up there called ioc.txt. It's just the one I use for my cryptography course. If you want to play with it, you should be able to determine that, again, E is the most popular letter in the English alphabet. Because the IOC is what I use in a project where we calculate it, and it's approximately equal to the English language. And yes, E is the most popular letter. Okay. Everybody see how that works? Kind of handy. All right, I'm asking you guys to get these to work because you will need them. Now, I have not put your next program up there yet because your Chapter 7 is not due yet. I will have it up there by Monday, probably sooner. But I want you to make sure you finish this other one. If I put it up there early, you can start with it. It's going to be using majority of this stuff. It's actually going to be calculating, yeah, it's going to be doing what's called the Kaczynski Method. Don't worry, but Cameron knows what that is. I don't think anyone else has heard of that yet. Maybe Brittany does. Brittany, you're in that class, aren't you? Cryptography? Oh, okay. I don't know if you were. You're in that class? Okay. So that's what it's going to be doing. And I actually...
don't know his name, but he's in your other class.
Right. He never comes to class, though. So I actually have the text up there they're going to be using for that. I just haven't finished writing the program for it yet. So, You know, because I don't know if you guys realize it. So those of you who've been in the degree program, I try to bring other material from other classes into other classes so you kind of learn it more. So that's why I think making you do stuff in here that's relevant in other classes will really help. Like Cameron just said, I don't know why I just didn't write a program to do the whole darn thing initially. Because, you know, at the beginning of class, I asked the number of earthquakes in Garfield County. Could you have figured that out by hand?
Yeah,
Yes.
you could have.
It would have sucked. Okay? So this way, it's very easy. You can, I mean, based on what we have here, could you tell me how many E's are in H.G. Wells' book? Actually, you could. Because it's right up here, L count. So you could have determined that. Very easily use this to calculate how many E's. And so on and so forth. So I'm trying to give you stuff that you can use later on. And, you know, it's funny. I teach a forensics course. I think, Brittany, you're in that one. No? Where are you? What course are you in?
This one only.
Jesus, you are
I'm in 2
lost.
other classes, but not.
There, maybe it's another Brittany then. Okay, but either way, their last project they had to break the password on a router. Okay, I tell them how to do it, and this one student is funny. She's been working on it this whole time. She goes, "You're not gonna believe this. I'm sitting at work today, and we found a rogue router that an old administrator left. We can't reset it because it does stuff, but we can't get into it. So she's using the exact same thing she just learned in the class this week to break the password on that router." She goes, "It's amazing. I just learned this, and I'm using it on the job." So it's kind of cool. We make you do stuff that people actually use. So, all right. And yesterday when I was doing that talking in Shawnee, I was sitting next to a guy who did the demo with Jello about earthquakes. So I'm like, I'm doing a project on earthquakes right now. So it was kind of fun. Then I started talking about earthquakes. He goes, "Well, technically, I don't really know anything about earthquakes. I was just assigned to do this demo with the children." I'm like, oh, how depressing is that? But, all right, so we're out of class time. Oh, by the way, the rest of chapter 8, I'm not going to cover it. I'm not going to test you on either, but it goes more in depth on different ways of breaking code. Okay, feel free to look at it. If I decide to incorporate any of it in something, I'll give you the code and we'll discuss it at that point. I just don't want to go over it all. Yes. Right where we just left off with the letter frequency thing. Anyone know what page that is? Let me go there. Hold on. It's on the second.
273.
Okay, 273. But yeah, hold on. We did that one because Wells on page 274. That's actually the one we just did. Okay, yeah, so I'd say 275, that's about it. That's where we stopped. Okay, yeah, because there's the get frequency. Okay, actually, that one's in there. 276 is also part of it. Yeah, so 276. The rest of this chapter is nothing new. It's just taking something you learned and using it a different way. Okay, you think about it. All we used today was lists, dictionaries, for loops, and if statements. We already used them all. We're just putting them together in different ways. Okay? So I just don't want to really walk through all the rest of the cryptography because he does get quite in depth on that. And I could literally take 2 more weeks covering the rest of chapter 8 when it's nothing really new. It's just putting it together in different ways. So we're going to start on chapter 9 next time. But I'll assign this program so. All right. The end of chapter 8.